Hi students, welcome to Future Dr. NEET Academy for the live session for crash course. Chapter we are going to discuss today is from chapter 4, Moving Charges and Magnetism. This is from 12th standard plus 2. Yesterday, third chapter we have discussed. Now, Moving Charges and Magnetism. This is from chapter 4. Okay. Magnetism we know. Magnetic field we know. What is the use of magnetism or magnetic field? Uses or application. Application of magnetism or magnetic field. Where and all we are using magnetism? Come on, say. Uses of magnetism. Best example, MRI scanning. What is MRI? What is MRI? Magnetic resonance imaging. In MRI scanning, magnetic field is used. That is, an intense magnetic field will be used in MRI scanning. Okay. And same magnetic field or magnetism is used to record the audio and video. That is used in audio and video recording. Also, especially what things means, that is magnetic tapes. Magnetic tapes, magnetic disc. Will be used. Olden days we used cassette recorder, cassette player. There will be a magnetic tape will be there that will be moving and then songs and all playing. That is called audio tapes. Nowadays magnetic disc, CD. What is CD? What is the expansion of CD? CD. Expansion of CD. Compact disc. DVD. Digital versatile disc. And HD, SDD, hard disk. Here and all, what is the use of this? What is the use of CD, DVD, HD? What is the use? Is? Okay. That is, we can record the or we can store the data. Okay. Actually, CD. What is the capacity of CD? Can you say? What is the capacity of the CD? How much bytes it can store? Normal CD. CD can store 700 MB. Okay. DVD. What is the storage capacity of DVD? Try to find. Okay, I think DVD you know, no? DVD everybody know. That is a CD, 700 MB, that's not sufficient. Even suppose, for example, you want to write one film, for example, one small film. That picture, that film will be playing approximately 2 hours. Then, if you use CD, it may take 2 or 3 CDs. We have to write 2 or 3 CDs to play one picture. For 2 hours picture I am saying. In DVD means more than 2 to 3 films you can record. Okay. So, CD, DVD, HD. What is HD? Hard disk. That is computers and all store data in hard disk. Hard disk drive. It may capacity may be in 40 GB. That is in olden days. That is in some years back. For my research, I used one system. That system, that capacity is 40 GB. Very low capacity. In the 10 GB will be used for C drive and remaining D, E there and all, remaining 10 GB will be used, and 10 GB is not sufficient, and many times when I record or when I want to write any DVD, any film or any marriage function things like that, then I have to uninstall some program and then I have to write. Okay, 40 GB is not sufficient. And nowadays 500 GB in hard disk I am saying. 1 TB, terabyte. 1 TB, 100 TB, like that. Its capacity is very, very high, and all these things uses magnetic pattern only, magnetic fields only. Okay, so we can store data in computer data and all using magnetic fields, magnetic patterns. Okay, that's the one important application. Another one, that is meters. All the meters, galvanometer, ammeter, voltmeter, galvanometer, all the meters, galvanometer, ammeter, voltmeter. What's the difference between these three? Galvanometer, ammeter, voltmeter. Or what is these three? Or what is anyone? Definition for anyone. Yes, measure the current. Which one? Galvanometer, ammeter, or voltmeter? Galvanometer. Galvanometer is used to measure current. What about ammeter? Ammeter also measure current only. Voltmeter measures potential difference or voltage. That is voltmeter. Okay. And in this chapter only, at the end of the chapter, this galvanometer only going to convert into ammeter or voltmeter, that we are going to discuss. At the end of the chapter, last three topics will be these only. Moving coil galvanometer. There, some derivation will be there. Okay. And from that, that is deflection per unit current, deflection per unit voltage, like that sensitivity of the moving coil galvanometer we are going to find. From that galvanometer, how it will be converted into ammeter. And same galvanometer, when it will be converted to voltmeter, that we are going to discuss, and we are going to derive the formulas also. Depends upon the resistance only, how the resistance are connected. When the resistance are connected parallel, then it is ammeter. When the high resistance connected in series, it becomes voltmeter. Okay. So like this we are going to discuss, and so all the meters uses magnetic field. Not only this meter, loudspeaker, motor, electric motor, generator, these and all uses magnetism or magnetic field. Giant superconductor, superconducting magnets. Giant superconducting magnets used to accelerate the charge particle. That will be used in cyclotron. In nuclear physics you will study cyclotron. What is cyclotron? It is one of the particle accelerator. So that is, for example, some of the charge particles that energy is not sufficient, velocity is not sufficient. So using giant superconducting magnets, it is possible to increase the energy or increase the velocity of the particle, and that velocity will be approaching to velocity of light, nearer to velocity of light. That much high velocity we can allow it to accelerate. That is the giant superconducting magnets will be used. So that one used in particle accelerator. So like this, lot of application in magnetism. Okay. Then moving charges and magnetism. That is only our topic. That is, charge and magnetism are interrelated, linked one. Moving charges are closely linked with magnetism or magnetic field. That is, moving charge produces magnetic field. Moving charges produce magnetic field. Same way, change in magnetic field generate electricity or electric current or charges. Electric current. that is only generator. Okay, that is generator as electromagnetic induction. We will see in next chapter. Okay. So charges and magnetic field are interrelated or linked one. That is, when charges move, magnetic fields are produced, and when there is a change in magnetic field, it produces electric current or charges can be produced. So these two are closely linked one. This was observed by Maxwell. First observed by Maxwell. Okay. Can we move to next topic? Biot-Savart law. Biot-Savart law. What is Biot-Savart law? For example, there is a wire, carries current. Okay, already we discussed, whenever current flows, it produces magnetic field. Okay, so current flows in this wire and magnetic field may produce here like that. And we are going to find at this point what is the value of the magnetic field. And this point is from the distance or distance. Okay, this point is at or distance from here. And we will take small length as dl. dl is the length of the element. Okay, dl is the length of the element. And then what is the magnetic field at this point? That is dB depends upon some factor. dB is proportional to I. What is I? I is the current flows through the wire, through the conductor I. Okay, and it's also directly proportional to dl. dl is the elemental length, small elemental length, that is dl, and it is inversely proportional to square of the distance between them. Okay, and one more thing is there, that is theta, sin theta. dB is proportional to sin theta. Combining all this, then dB is proportional to I dl sin theta by r square. By removing proportionality, we will introduce constant. That constant is dB equal to mu naught by 4 pi into I dl sin theta by r square. So this is the expression for Biot-Savart law. Biot-Savart law says that magnetic field produced at a point due to current carrying wire is proportional to magnitude of the current and directly proportional to the length of the element and directly proportional to the sine of the angle between the dl and the point between dl and a particular point P, and is inversely proportional to square of the distance between these two. And combining this, dB equal to mu naught by 4 pi into I dl sin theta by r square. Okay, and you know I dl sin theta can be written as I cross dl. Okay, that is a cross product. Therefore, dB equal to mu naught by 4 pi, I'll write off better. I think this we have written, no? Then we can write this as dB equal to mu naught by 4 pi into ideal by R square. And this dB is a vector quantity. And here we want to introduce a vector, that is R cap. Then R cap is a unit vector. R cap equal to, what is R? This is a R. What is this arrow mark represent? Vector. R vector divided by modulus R. R vector divided by modulus R. And if you substitute this here, dB equal to mu naught I dl into R vector divided by R cube. R vector divided by R cube. So dB equal to mu naught I dl R by R cube. This is in vectorial notation. Ideal is another vector. So this is the vector rotation of dB. And what is the unit of magnetic induction or magnetic field? Tesla. Its unit is Tesla or Weber per meter square. Weber per meter square. It's measured in Tesla or Weber per meter square. Next topic. Magnetic field due to long straight wire carrying current I. That is B equal to mu naught I by 2 pi A. Suppose this is a long straight wire carrying current and this P is a point at A distance. Then B equal to mu naught I by 2 pi A. This is the formula for magnetic field due to long straight wire. Next topic. Magnetic field due to a circular coil carrying current. Magnetic field due to circular coil carrying current I. This is a circular coil. R is a radius of the circular coil and we want to find at a point P. B equal to mu naught I R square divided by 2 into, this is at x square, 2 into x square plus R square whole power 3 by 2. Okay, B equal to mu naught I R square by 2 into x square plus R square whole power 3 by 2. R is the radius of the circular coil. R is the radius of the circular coil. And x is the magnetic field due to a point P at x distance from the center. center of a coil. O is the center of a coil. Okay, and so B equal to mu naught I r square by 2 into x square plus r square whole power 3 by 2. Then, suppose the point is at center. If the point is at the center, then what's the value of x? This point is here itself. What's the value of x? X equal to 0. Then B equal to mu naught I r square by 2 into x is 0, then r square whole power 3 by 2. Then mu naught I r square divided by 2 into r power 3 whole r square whole power 3 by 2. So this square and square root getting cancelled. Then 2 into r cube. Okay. Then r square and cube getting cancelled. Then B equal to mu naught I by 2r. So this is the magnetic field due to a circular coil carrying current when the point is at the center of the coil. And when the point is at x distance from the center of the coil, this is the formula. Okay. At the center, this is the formula, and at x distance from O, center point means this is the formula. Okay. Next topic. Okay. Next topic. Force between the two parallel wires. Force between the two parallel wires. Two parallel wires carrying current. Carrying current I. That is two wires, which is distance d distance. Okay, and there may be a force. That force is F equal to mu naught I1 I2 divided by 2 pi d into L. L is the length of the conductor or length of the wire. Mu naught I1 is the current flows through first conductor, first wire, and I2 is the current flows through second wire, and D is a point of separation between the two parallel wires. Okay, and this is the force between the two wires. And if both the current flows in the same direction, then force will be an attractive force. That we can say for parallel current. For parallel current means this is a parallel. I1, I2 acting in the same direction. Then the force will be an attractive force. It is an attractive force. For anti-parallel current, that is I1 is upward, for example, and I2 will be downward. Then it will be a repulsive force. Repulsive force. So this is the force between the two parallel conductor carrying current. Suppose the length of the wire is infinite length, then how can you measure L? The length of the wire is infinite length. What is infinite means? Infinite means? Unmeasurable. We can't measure. Very, very long value. Then, how can you measure this one? Means, we can write this as force per unit length is equal to mu naught I1 I2 by 2 pi d. Force acting for 1 meter length. Okay, force acting for 1 meter length equal to mu naught I1 I2 by 2 pi d. Okay, like this we can measure. And for this also same principle, if the wire is parallel, if the current is parallel current, then it's an attractive force, and if it is anti-parallel, repulsive force. Okay. And next class, in next session, we are going to discuss solenoid, toroid, and moving charges in wire, that is in cyclotron, and that will be applied to moving coil galvanometer. And from moving coil galvanometer, how galvanometer is converted into ammeter, and how